Okay. It's 2:30 here. I opened the chat room a little late here, so usually I would open it 10 minutes early. So I'm just going to go around and just ping people. So that everyone is aware. Okay. Right. So this was going to be coding a bit of compiler coding. So let me just start. I am doing this. We have the costs in C3, which there are a bunch of different costs. So let's just like this. So we have it's a into bool, enum tween, blah blah blah. Lots of these. And the way we have been working is that this is kind of ordered now. It used to be more ad hoc, and believe me, that is a nightmare. Anyway, going into one of these functions. So you get like this, right? So it's like a cast any fault to bool. It actually does a rewrite into bool of that any fault. So before that, most of it looks like, let's see here. So this like this. So there were a list of costs, and these costs would run at be lowered at the LVM level. And now, a downside of doing like this is that when you want to do another backend, then suddenly, I just hope that I haven't turned on. So we have mic, yes, sound. Hope things sound okay. Anyway, so the problem is that then you have to duplicate this, and you also can't do any analysis, or you can do that, but you have to look at through these costs, and it's not very nice to do that, honestly. So what you want to do is, what I wanted to do was to move these costs into actual new expression nodes. So what I have been doing is that, so expression nodes, so we have an expression and that will be lowered to something. There are a lot of different things that can happen, so we can look at these different kinds. So we have some of these are obvious, like big workhorses is the call, obviously. And then we have like the set of binary expressions. Sorry, here, let's see here. So we have the binary, which is also like a huge thing, and you have the unary, which is like minus and the ref and so on. Then you have special one, ternary. And then you have the special ones that are kind of this is the slicing operation, But I added some new things. So these are new. And this is new. Now the kind of front end knows that, oh, I'm slicing a length, taking a slice of a length, a length of a slice, so a length of a slice, and that can be used later in the code because it now knows more about it than it would before that. So we have a bunch of costs that need to be converted. But there's also these built-in functions. So we have a set of, let's see if we can built-in by name. Okay, so there are a bunch of built-in functions, and some of them, and these are like these look like maybe something like this, C2C, and some of these like are basically just accelerated function calls. Or actually most of them are. But what I've and I used to be like, if I take something like this, so then it's lowered again here at the at the LVM level, and the downside here is that by doing that, you have to kind of essentially you don't see this like opaque until you get down to the LVM level. So you can't do any flattening, you can't do any analysis and so on. So it's good if these are moved into normal nodes, normal expression nodes. So, but we're starting with the costs, and this is like a long-term project because there are a lot of them. But once you're done with that, so when you want to do a backend, you have to reproduce these like the same behavior. So you have to copy paste these, and if something changes, then you have to copy everything. So you want to have that this kind of the set of expressions becomes like the set of instructions in a intermediate. It is more of an IR at the point it comes down to LVM. So you want to have it small. So it's like a risk sys kind of situation. It's like just a pain if you have a lot of these different nodes. So what happens now is like I extract some of these nodes could be like have subnodes. That's what essentially happened with the costs. That the cost has a cost expression actually has a lot of these, and there used to be much more of these. And I can kind of, if I can extract these into functions, sorry, expression nodes, normal expression nodes, maybe I can reuse them and I have more check what is actually happening. So let's just look at this one, which is like a boolean to to I think like a floating point, right? So it's just an extension. And then there's a question there where this is like the same thing. Let's see here. So we have something similar, I think. So we have the general floating point to something. Oh yeah, here it is. So we have this general floating point, and those are pretty much the same here. So we have this one and this one, right? So they are very much the same. It's less a bool. It's kind of a it becomes a unsigned integer basically. And then we can kind of do this. We're going to look at the expressions. So just going to jump into the expression. Oh, sorry that I can't jump fast. So we want to have something expression which is called expression int to floating point. So we put it here, into float. And now we have to have that one everywhere. So how is that going to look like? It's just going to have a type. The internal type is going to be like the int type, so it's going to know what the inner type was, so I don't need anything special for it. So I'm just going to use this pointer access and kind of trace. Here's the C backend. I'm just going to paste so that this is handled here. So let's see here. It's like a into bool. No, into bool. Wait, is there an into bool? They call it. No. So it's an into float chart. This is what. Oh, if I have it into bool, it should be the same as the into bool. So okay. And there's a rewrite, and there's the span. Let's see. Oh, it's a negate. Okay. Case expression. There's another one which has. Here's one. Case expression in to float. Yes. We're gonna have a copy. Too. It's going to be again. I want to follow this one, which is more. It has an inner expression, and that's all. It just has this its type and this inner expression. Is it pure? Is the runtime constant? Maybe it is. It may be. Because if I do this, if the inner part is constant, I know this will no. You can't do that, right? So it's not an address. And what is that? It's like into float. It will look like I just do something. This is going to be like wrong because basically, what is this? It's print type. I didn't do these things. I didn't basically I don't expect this to be correct. So print type, what's that? Type info. That's weird. Ouch. I don't even put it to do here. Okay. Maybe it will work, anyway. And okay, because C has loose rules. Okay, so that's another pointer. That may ref. No reference to this float. The dispatch, let's say it should never happen because we should always have been resolved that. Okay, it's an L value. No, it's absolutely not an L value. So should I put it in here? Oh yeah. And then is it defined? That depends on what inner was. Okay, liveness. Yes, we just look at the inner part. Can it be a try expression? Yes. Okay, so let's see here. So we're not done. So I'm just going to run this and then it's going to break. There it is. So we have this LVM yan, so case. Now we're going to take this and make that into a one of those. Let's see, cost. Emit cost. We're going to pull out the code from here. And as we do that, we're going to kill this code too. So we have this. So now it's actually just it's not really doing anything new. It's just changing where we have handled it. So where is it? Int to float, yes. So you're going to turn this into an R value. If it's a signed type, then we're going to go to the type, which is going to be the expression type. And then we're going to, otherwise we're going to do this one, and it's going to work for the bool as well, because the bool is not assigned, so it's going to say false for that one. So that one would be return, and then we do a return here. Let's see here. So we're gonna go through for the R value. So low what? So okay, it's not. First, we want to emit the inner expression there. So it's emitting the expression, and now we turn it into an R value, which basically it loads it, whatever it is, because we want it loaded. Otherwise, we can't do these conversions. And then we're gonna look at the type. Is the look at whatever type is, and then we're gonna change the underlying type to whatever that type is. So we can actually do it like this. So if it's signed, then we do an LLVM value set. Now we have the value, and we want to have this thing, and we want to have the new type, expression type, like this. And do the same thing, but we change the function. And then we're done. So like this, right? Let's see if it compiles. And have you tried Hungarian notation? What? That was a random question. Yes. Back in the days, we used that a lot in C++. Anyway. Still feeling my cold or whatever it was. Okay. Seeing some questions. Oh, the link. I didn't paste the link to people for the for this Twitch chat. So let me just post that on the C3 channel. So Discord, sorry. While it is compiling a bit, so we can. There we go. Okay, so it seems to pass some of the tests at least, but we didn't do. I think we didn't really kill the cost code yet, right? So we're gonna kill. Now we're gonna kill the cost code. So here's the cost, right? So we had in here. We do this bool to floating point. So this one, wherever that is, so it's inserted here. Now I want to create a new rewrite. So we're gonna have let's say inline rewrite, and we call it into float. And we're gonna have that, and the resulting expression, and the expression is going to be a copy of the expression that we had. And then sorry, I'm doing this pretty quickly, so we're gonna we have the int to float. So this is basically a rewriting. So this is kind of a wrapping. It's going to wrap an into float of that this particular expression going to be wrapped into an into float. So okay, let's see here. So the type, the inner type is the copy and the new type is the type. So now we can replace this in the these cost of float. So here, if not expression cost, let me look at this one. Not semi-cost const expression of, okay, so if it's not a constant expression, what we're going to do then is going to rewrite it into an int to bool, no, into float, to int to float. So we're going to take this expression and we're going to have the type, right? So, and it's done. Okay, and then we have a similar thing. No, that one is bad. Okay, we're gonna look at that later. So we're gonna rewrite that into float, and then we have another one. So we have this one as well. This one is also like that. So if not semi cost const, in that case we're going to rewrite it like that and then return. So, and then we have these are broken. These are bad. So this is for, actually this will work. So this is converting something into a float. So we can actually write this. So we're going to write this into int to float. We just need to be able to say, we have to look into the this is going to give us the wrong thing. So here, like this, let's see here, we have this one here is looking at if the type is assigned, but we want to if it's a, you know, if it's if it's not a vector, it will give us the vector type too. It will look through the vector type. That's good. That's super good. So okay, so then this will work, right? So that one will work. Let's see where we had the usage. Okay, so we have there. Now, okay, we have this one as well. So bool to floating point. And again, we have this costing. So this will work. I will rewrite this one. Rewrite rewrite it into float. So to type. Okay. And that should be okay. So now we don't need these, but let's see that it actually works. So let's see if there are 3 viewers. Any questions, just put them in chat and I'll try to answer them. So now this is kind of, meanwhile, like these are 900 different things that are tests that are going to run. Meanwhile, we're going to kill these. So we can kill that one. Oh, wait. Enum cost failed. Woohoo! Yes, baby. This is going to be interesting. So let's see what happens differently, right? So now something is different. This is why we had a regression test. That's why I can do things fairly aggressively. So, okay, let's see here. So we have a test on this enum cost. Enum cost is the thing that now doesn't work correctly. So let's see what happens. So the enum cost is now, so I'm looking at the diff here. So okay, so before it was a, oh wait. So let's see where the changes. So okay, so the pointer here, reloading the pointer from x. What is x? So x is my enum, right? So it's a char because it was a char, right? Okay, yes. Then oh, ouch. The name. Like, look at this. It's just the name that changed. So the name changed of these. I think I did when I did the copy paste. I just call them the same thing. And this one is the signed, yes, and this is the unsigned, right? And then so the test they failed. So let's go back and just run that again. So LVM allows you to set a name for an intermediate result. In this case, it should be like SIFP that I had like signed integer floating point, kind of the conversion value there. And then for the unsigned, I should have UIFP, but I did a copy paste of things and then I kind of left it there. So let's see if you have any questions. No questions so far. Just feel free to ask them. Okay, so it's probably going to work. So meanwhile, I can just continue that the removal of these things that I was starting. So we're going to remove bool to floating point. We don't need that anymore. And int to floating point. And that's going to be very, maybe can do like this. So let's get those back. And then I'll look for usages. And then I kill those usages instead. So this is not going to happen anymore. And then the cost here, this is gone. And then we have the int one. So we have this one. Let's see where that one is used. Let's remove that. And let's remove this one. So now I can go back here and remove this one and this one. Okay, so one less conversion. The goal is to kind of remove all of these, so there are no costs. Like the cost is just going to be, yeah, the cost. So we have like so this is interesting. So we have the floating point to different things. So we have the floating point to, oh yes, the int, right? But that has to be like its own. Unfortunately, that one should, in order for us to kind of have a good control of everything, that should be an expression. So we have like an expression which is floating point to fp to int, right? So and that one is just going to float to int, right? So we introduce that one. We have it already into float, so we can just have that one. It should behave in the same way, right? So we can just look at where int float is, and okay, we're gonna make that one later, but this one, float to int. So unfortunately, we can't make them kind of cancel out. That would be nice, but you can't do that because of obviously there is the whole rounding thing. So we have the int float. We can do that last. Just now is follow and just do these very simple. These are explicit here. You could have like made them in default, but it's good to have them explicit so that it's easy to inspect later on. Okay, so let's just go here and implement this. So float to int, we have that already in the costs. So mid cost. So somewhere here, mid cost, that's the name of it. Okay, so we have this floating point to int, and let's go back, and then we have, so this was JSON input, went too far. So float to int. So we have an R value. We're going to do the same thing as before. So we're going to have like this and then turn to a value. And then we're going to look at what is it signed, the to type. So the value that we're like turning it everything into, is it signed or not? So the expression type. And now we need to flatten. So flattening means that we remove all the, no, sorry, lowering is even. So we have to lower this and remove all distinct types and so on from this. So okay, and then we have like to type, which is the expression. And then we end up similar to this one, so we can do the set actually. So we can do that. So LVM value set, and then we have the value itself, and then this part. At the end, expression type, like this. And then everyone remembers that I copy pasted, and then I forgot to change the name here, so we're not going to forget that this time. So like this, and like that. So now we have an instruction that is basically, this is basically becomes like an instruction for us. So let's see if I forgot some place where it should be in. And well, I did. So is it the pure? So then it is so it's like similar to, let's see here. Where is our float into float? So okay, yes. So it's, this one is a pure function, the pure expression if it's the inner expression is pure, because it doesn't change anything. Right, so now this works, I think, yeah. So now we still haven't replaced anything. Okay, so any questions? So right. So let's see here. Okay, so we're going to go and fix the costs again. So we're in the enums. So we have the cost. Right. So we have the floating point to int. This cost. This is the one we're gonna get rid of. So we're just gonna kill that one. Well, this one is not gonna happen again. So we're gonna kill that one. And then here, you're gonna do an expression cost. Cost. I forget, but so let's see here. So it's called semi-cost const. Okay. Semi-cost const. This one will is a little special. Okay, so anyway, if it's sure not to be a constant, then you're gonna rewrite it. No, we didn't have we want to have this expression rewrite. We have the int to float, but we want the float to int. So it's going to be like extremely similar. So float to int, and then we just need to type, and then we're done. And so now we don't need this floating point to int anymore. Oh, we have the bad the vector case, but we're going to call our float to int as well, and it's going to work, I think. So now we don't have that anymore. We'll just try to run this. Maybe it works, maybe it doesn't. Right? Now we're going to run all sorts of tests on it. And questions? So feel free to ask. See a rate here. All right. So we're doing compiler refactoring basically in the C3 compiler. And this is to make it, you should really go through the code every once in a while. Make sure that it's you don't have cruft. The bane of everything is like the cruft. Let's see where this is used. This is going to be interesting. So this one is used if the AST is compile time, right? And if an expression list is constant to val, yes, but is it? I wonder. It's like sometimes I have these and then, yeah. So this expression can be evaluated till compile time. So there are some things right now anyway that is constant at lowering time, but it's not constant in the compiler. So that's why I have this, which is a bad thing. It would be maybe nicer if everything in C3 was doing the same thing. So it's every runtime constant was also a could be also be lowered, but that would have to be a bit more complicated in order to do that. So we have this actually used a lot. What else can we look at that has these? Usually doesn't do anything. So let's see what we have. The pure the address. So I wonder if this could be used, make it a little simpler, because there's so few things that you can actually address. So I mean, in the case you have like basically what can address the bit access, yes. The access may address in some cases only, actually. And the uner, the ref may access, you can take an address of that. And this is just going through. Everything else shouldn't do that. So maybe you could, maybe we could actually remove this. I don't know. All right, but let's look at where we are at. So all the tests passed. So what we've done now is essentially removing 3 costs out of we have remaining 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So let me just refactoring, very, very expensive, removing costs, cost types. So I'm just going to commit this and push it live. So okay, what C3 is? What is C3? Yeah, C3 is a programming language. The C3 programming language is, let's see if you have some examples here. So a very C-like. So here's something. This is binary digits. We have a brainfuck interpreter here. It should look a lot like C. But you have a bit of semantic macros and so on. Game of life. Right. So I don't know. Maybe I'll just like this is kind of boring to look at, right? So but I guess I'll I'll do one more or so of these. Let's see if we have something that has a lot of bang for the buck. Let's see at these. What I want to remove is basically, okay, look at this. So we have all of these three. They're all doing exactly the same thing, which is like running the into pointer cost. Into pointer cost is weird. But okay, so we're gonna introduce an expression which we call, not surprisingly, into pointer. Or is it an int pointer, right? It's an int pointer, yes. Into pointer. And it's similar to pretty much anything we've done before. So we have like we can just follow this one into float and then write into pointer. And then we're gonna have like, okay, we have this span. Well, it's just into pointer. And then you're gonna have the int float, yeah, into pointer. This is pure. It's the runtime constant. Wait. It into pointer can definitely be a runtime constant. So yes, it can be that. Is an address? No. And can we print it? No, because we don't have a type. So we're going to look at also the implementation, but also the usages everywhere. So we made ref that one. No. We don't have this because it never does it. Is an L value? No, it's not an L value. Is it defined? Let's look at the underlying and this. Okay, so is the value right? Yes. It's kind of like answering a couple of questions about it. Okay, right. So now we're gonna need a rewrite. So int pointer into pointer, and that's all. And now we're gonna look at the cost and how it's used. So we have CMA cost. No, sorry, it's an LVM emit cost, right? So something like that. So we have these pointer. Let's look at the into pointer. So into pointer, let's see how is that used. So it's a runtime. Let's see if there is something else like cost and into pointer. Cost ActiveEc, it's also used there. So okay, let's implement it. It's going to go in here. Into pointer, and we're going to have like this, and then we make a value out of it. We're going to get the resulting type. We're going to do like this. So set value set value. And this is the result, and then the type is going to be here. So comma expression type. Right. So now there's an integer somewhere here, and we're going to build an into pointer there, and then we're going to return. And then we're going to look at all these into pointer costs. So, okay, so it's always fixing that. So we do a rewrite. Into pointer. Right. And then we have another one here. It's also going to be an into pointer. another one here. And then let's see here. So then we're going to remove all these other things. So into pointer, yes, it's going to go. It's going to be gone. But we're also going to remove a bunch of other things. So we're going to do error to pointer. So where is that one? Here. So rather than doing this, we're going to do a rewrite into pointer expression and the type. And then we had another one. So now this one is fully gone. And ID2, so that is the casting a type ID. Do this, oops. So it's going to rewrite it, so like an into pointer. Because we don't have the ID, it's when we have an ID, type ID, we cast a pointer to a value, and then we pass that around as a value because that's just nicer to read. Okay, so those were those. So we're gonna remove this one as well. We can remove these. We can remove these. Let's see if there's something else we need to remove. Oh, and let's see if it worked or if I did something bad. Okay, let's run that. Let's see if I have any questions. So, how does C3 compare to the likes of Zig and Odin? So, C3 looks like C, and Zig looks like Java, and Odin looks like Go, right? Verbose compared to C. Okay, no, it is the same as C. So that was a very weird thing. And why do you think it's? Why do you think it's verbose compared to C? I'm not sure, because like what we're looking at now, this is the compiler, which is C, right? And then, yeah, here's some C3. So this could essentially be, this could be C. So I don't know why people are saying why you say that. That's the weirdest thing. Like more verbose compared to C. Yeah, but you can write exactly C programs in this. So yeah, I that's weird. Maybe you should look at C3 again. It's yeah. And this seemed to be working most of it anyway. No weird miscompilations, which this test suite is. If you see this one thing here going down here, that's going to look at the LVMIR and see that it's the same. It compiles to the same thing. So we're mostly okay, I think. There are a few, 50 or so left to go. But we managed to reduce this. So here's an interesting one. It's interesting because I think there is like the from ordinal is using the cost, but this should really be a function. So, and there's this interesting thing here that if you have this cost, then and you go back, you can kind of go back into the at compile time. It's if you have from ordinal to ordinal back and forth, you should be able to custom move them back and forth. So let's hear why it's. Oh, the FN. So the FN, yes, it's you have the FN, right? More verbose. Yeah, but look at this, right? So yes, that's more verbose, but in C you would have to write like it would be like let's me write a struct type struct foo. You would not usually not write it like this. You would do like type def struct foo. Maybe you would remove this. So yeah. So do you win anything by like doing being able to do that? Yeah, it's C3 has this. But yes, there's an FN. So the reason for the FN is really there are two reasons for having that. So actually three. But let's like the thing is if I write a function, then that's fine, and then we'll write a macro which looks like it's just very symmetrical here. And you can also grep for everything that starts with fn, so you can get to the functions. So if I go like fn, I'll get my functions, right? So that's nice. And then fn is also used when you define a type in a type def to avoid the kind of the weirdness of in so you want to have a void function, then you can do, like that. So it's there's use for that. Actually, the function actually this comes from C2. So C2 has had actually like this func for everything, and I reduced it to fn, and then C2 also did that. So that's at least I'm contributing back to C2. Anyways, it could be removed. It could be removed. But then you would have like a macro and the void assist. And then you have like the lambdas. So if you have a lambda, you want to do a lambda, a boo, and it's kind of more, and you use this to kind of make it simple. Oh, this is the short syntax. Short, you can write like this as well. Then let's make a main. And then I can print boo 4, right? I run this. Oops. Oh yeah, forgot to now I'm being lazy. I'm including the old stunt library. Void, yeah, did I? Oh, yeah, good. No, it's giving me 16, right? So I can reuse that. So that's also convenient with FN. I can like this too. A bit shorter. And if you already have a function, so you have already defined the function type like this, I can infer more things. That should be okay, right? Let me think about that. Maybe I should. Yeah, that works. So this is why FN is also convenient, so you can do more shortened syntax. So this is kind of nice if you just want to put it in like a callback or something. Okay, that was a part. So your accent sounds somewhat Swedish. Yes, I'm from Sweden. I am from Uppsala. So hej från hej Växjö. Oh. Yeah. All right. let's go back to okay, do you have some other questions? Right. Okay. Then let me just poke this one, because otherwise we'll get too much of a diff here. So we got all these replaced by this pointer. So removing, introducing pointer expression, right? Everyone else has to do. I kind of feel bad when I do like that, and everyone else has to do pull requests. I'm just, let's push to master. Yeah, the privileges of being admin. Okay, so let's go back and see here. We have the FP to FP extension truncation. We have the pointer to bool. I wonder if that. I think this one is only used for vectors, and I don't think it works. So, yeah, let me try to prove that this doesn't work. So we have a vector of 2 pointers, and just the guy is going to be a null. It doesn't matter. And now we're going to cast this into bools instead. So this is a valid conversion, and it's going to use that code, and it's going to break. I'm pretty sure, because it looks incorrect. Let me see. Boom. Explosion. So this is incorrect. And the idea that it wants to use is there is let's see here. Sorry, I'm getting like lost my train of thoughts. So we already introduced some of those. We introduced something called into bool, and that one is actually, and we are doing this rewrite into bool. Let's see here if we have that one. So we're doing one there. So let's see here. So we have an into bool. Pointer to bool is also doing the same thing. So the question is if whether this works or not. And I'm going to try to experiment with that. It probably doesn't work. So we're going to go back to where that one was used. Pointer to bool. Pointer to bool. Only used here. Probably worked at one point in time. So we want to rewrite this into bool, and then we're not going to negate that one. Oh, so okay. I think this one is assuming that the result is bool, right? So that one is bad, but we can do our own. So we're going to do copy, and then we're going to do an into bool, and then we're going to take like, okay, not negate false, But then we're going to change this type to the whatever type we want to have, and then we're done. And now we're going to look at the into bool, how that is handled. So if it's, yeah, this should work. Let's see if it works. I'm not 100% sure it works, but maybe. False, false. That looks good. What if we take like an int here, and then we grab... Oh, I always use x and y for my my variable names when I test. Then I run into those bad problems. Well, it works. Then we can probably make this into a test, actually. Cost, bool. Here are a lot of these costs. So we're going to have a new file, which we call cost to pointer to bool. Right. And in order to get some cogen, we need to have the target, or we can get it without target, but then everything can be messed up. And we're gonna have a name for the module, so we get a reasonable name. So this, and then this will break. Just gonna use it. Meanwhile, I'm going to look at this broken thing in the costs. So cost okay, that one is okay. Oh wait. So let's see, CMA cost, LVM cost now. LVM, emit cost. Emit cost. So now we can kill this one. No, not the one. Pointer to bool, this one. Because it's just here and here. Just remove that one. Then we can kill off this one, which was incorrect. I could make that one work, but better to remove it. Now, let's see and look here, and then we have this error that we expected. And it's going to be a bunch of code. I usually do it this way. So now I get the code that was, incorrect in our new output. So let me paste that one, and then we're going to trim it a bit. So we only want this kind of great thing, and let's see what the code does. So it's going to insert these elements. So it inserts a pointer and a null, and this creates the vector, and then stores the vector, and then it does a comparison with 0. And then it will finally, it will store it, yeah, it will store it as, it will do the extension and then store it as chars, because it shouldn't be, when it's like a value you can pass around as a 2 times I1, but otherwise it's just bad. So okay, and that should be it. We can remove this part too. Okay, so let's run that. Let me look at chat, see if anyone has some questions. No questions. All right. Everything is crystal clear. So let's see here. What do we have left? What kind of cost do we have left? We have the error, which is a failed cost, a oh well, this is like a special where you convert a fault into another fault, into a general fault into a fault, and you could actually improve this one. So I've actually made a improve fault to error comparison where you could have a check that they belong to the same group of errors. I don't have that right now. On this one, then it says this is this actually? I mean, all it's doing is like a comparison to zero. So we can actually do an expression, rewrite this as a lens, like a slice lens. Okay, so we write this. We make a copy of the slice, the inner code. So it's a copy. So now I can remove this because I've done some work before. So I'm going to rewrite this as a slice length. Actually, I need another copy. Which is another copy of this expression. So we're going to have the length is going to be the inner part, and the type is going to be this. And now we're going to have a comparison with zero. So we're going to make expression binary. So you're going to take that one, and the left-hand side is going to be like the length. And the right-hand side is going to be an expression which is a const new const int. Again, we're going to grab this span. The type is going to be the same, and we're going to do a comparison, and we're going to see that it's not equal to zero. And then it's going to be so like this. So this should now be this thing. So we have an int. And now this is empty. And then if we cause it a bool, we're going to get something. And then we have another one, which is like y, which is one element. And we're going to cause that to y. And now let's see what happens. Did the other tests go? Well, they passed. Now things might. Oh, it broke. It broke completely. So I did something bad here. Let me just pull this, grab this, and just insert this slbool thing. Right, so this worked, just to show this works fine. So there is something wrong in this code. Okay, so we're gonna rewrite this is length, and then, oh, hang on, did we? Oh, I didn't set the type of this binary, and I didn't call it resolved either. So, so the expression was to have a type, which is bool. No, it's going to have a type of type actually. And now then, let's see if this is if it's happier now. Yes, now it works. So what just that. So now we could remove that part. Let's see if what happens if I just run the test now. It might be different because I have it could have slightly different code gen. So this is in the front end basically, right? So that will so now the front end knows basically how the costs happen, because before they didn't. Like before, the costs were kind of, yeah, something magical happens to the front end anyway. Something magical happens, and then it turns into a bool. Now it actually knows what happens. So it goes through, it grabs the slice length, it does a comparison, and then you get the result. So that means also like anything that we do with static analysis, we'll suddenly know what this means without having to have something special for the cost. So you just need to understand the slice length. So the slice length is often possible to infer. So then we can also infer what this is, and you get like a lot of static analysis that is possible. At least like if you know, okay, if there's, you can kind of look at different possibilities where things could possibly work or not work. Okay, it mostly works, and then I should be looking at this, removing this part with the code again, like this one. So that's the one which now has no use anymore. So this one goes away as well. Okay, so we just stuck with this set of entries. The vector to array cost, the array to emit array to slice cost. So we're converting an array to a slice, which it's that one is simple. And then we have this pointer to int. I wonder if this is, so it's actually used a bit. And then we have this. This one is actually something we should do. And this one is important, the int num one. But then we're almost done. It's like it's almost finished now. So, here are the costs. Okay, maybe I should just wrap it up here. So if there aren't any questions, then I might just end here, or maybe I should do some other things. So okay, this is these are our changes. I guess like about as many it removes as much as it adds, basically. But in the future, this means that some of the code that I encounter in the code gen could be turned into front-end code. So that's the advantage here. Some of this. So this is just, let me see here. So we have the built-in functions, the values, that's nothing. Oh, C3 has to, like the things you have to handle in LVM is basically that sometimes you have the address of something, like an address, if there's a value like a struct, then usually it's, you actually have an address to it, not the actual value. But if you have something like a vector, then you have the value. If it's an array, you usually have the address. So you have to handle that, and then you have to handle the case where you have an optional with some pervasive kind of almost like exception handling is what you have to do in the compiler. Not that the compiler is having an extra exceptions, but you have to do jumps as if you were compiling something with exceptions. Yeah. Let me see here. It's like everything passes. So then we're gonna just going to document this, and we have remove refactor costs, removing a spool, and what else, and pointer bool. Actually, that was fixing a bug as well, but I guess no one is using this, like doing vector stuff. But it's kind of neat. You can like vectorize the handling pointers. Okay, so I'm going to go into the list of issues here. I'm going to fix some bug. So missing macro if symbol is not found. So let's see here. Okay, that was just an improvement. Param missing is doc leading to, okay. Okay, so let's see here. Do we have anything that's really a bug that I can do? I'm looking at the issues right now in the C3 issues. So let's see here. Segmentation fault, compiling in NixOS. That one was difficult. So okay, so we're gonna have a look at one. The name of this one is this. So it says this. Macros with trailing bodies aren't allowed as a single statement after while with no body. And what happens is this. So I have some code, which is not quite. Okay, so let's do it like this. So this is going to explain what it does. So do something. Okay, 1 through. This should be okay. The only thing we wanted to avoid was basically having it like this, right? So why is this not okay? So let's see. So loop start, we have to create our function. So loop start and void loop end, and we can do what? We have to do something. Okay. So let's just ensure that this is not working by running it. A single statement. So let's we actually add a break here. If we suddenly run it, well, it will just otherwise we'd just run forever. So okay, now we have something like that. Okay, so a single statement after while. Okay, a single statement after. Let's look at that one. So I think what happens is like, okay, so if the body is not an ASD, right, and the row of the previous span, I think if it's, so this is like the row before parsing the body and after parsing the body is not the same. So, but what we want to do is like this. So it's, so if the body so we kind of want to avoid doing weird stuff, but we'll fix that anyway. So okay, so like if the body span and its row is not the same, so this would allow it, I think. Now it's okay, right? And let's just make sure that we're not breaking anything. So if we do like this, it should still be an error. Yeah, so this is like, now it's doing the right thing. So what happens with for loops then? So we can do a for loop, will be a similar thing, right? And there's a for this, okay? What does it say then? Here it will. Oh, it's fine with that. So in that case, it's okay. What about an if statement? If true, and then I go like this. It was just a while statement that had this problem. So if statement, that's here. Oh, I had a break. There's no break in there. Yeah. So let's just have some fun. So loop start, and then we have loop end, and then we have just do like this. And it's just going to print, do something. Let's see if I'm allowed to do this, if I have to cast maybe to void. Yes. Okay, so we go into the loop. It does do something and then it breaks, and then we'll go do something and it breaks, and then we're going to do something and we get the loop end. Yes, that looks right. Okay, so then this is fine. Let's see if we break any tests. Meanwhile, I'm going to write up this. So actually it's a fix because it's... Oh, wait. What happens here? So 2000, suddenly there's an error. So let's see what happens. So we are in... Oh, let's see here. We are on line 270 and then we get an error. So what is that? So we get... Oh, what the heck? Right, I must have broken something. So this is important. So let's see here. Run single standard library. Right. So a single statement after a while must be placed in the close. What? Okay. Let's go back to the parser and where the whole thing was handled. So we're not in that, and the body itself is not in the same span. What? Okay, so the body now is just a nope statement, right? And the span of that one is, it's on row 16. And the previous row was what row? 15. How come it's on 16? Oh, that's super strange. That's probably something about, like, if you parse a statement and you get like just a semicolon, and then it's placed on the next line. Oh yeah, look at this. So it does an advance, but so this is wrong. So now it's going to be right. So unfortunately, I don't like this. I prefer how it's like in a bunch of other languages, including C3, where you don't have to open the scope. Okay, so now we should be more happy, right? And let's see here. So now it works. And let's see that everything passes. So, any questions about programming languages, compilers? Feel free to ask. You can post it on the chat and I'll try to answer it. But right now we're fixing a bug. So meanwhile, now since it's now looking better, so we're gonna go to the closed the everything for myself. Okay, so we're gonna go to files, release notes. I don't think you see my pop-ups. But you see this, right? So what was the name? So macros with trailing bodies are not. This is going to be a long one. Let's copy it. So macros with trailing body aren't allowed as a single statement after a while loop with no body. Okay. And then we're going to put this one in here. But also, it would be nice to have the checking somewhere. So we had this one, which kind of had some. So maybe we just do another one. So macro, a while, statement placement, right? So then we can just paste in this stuff. Just make sure that you don't get. Oh no, we have to. Do another one. So while statement placement. The reason why I have to do another one is that sometimes parsing things that fail will then make the rest of the things not check. So while statement placement 2, C3, and then I just grab this stuff that we have, and we should just see that it should just pass. It should be just no error, and that's the test. And since we already checked this pretty much, I can probably check it in, but maybe I should wait. Meanwhile, I'm going to look at this. I'm going to assign myself to this task. And there are a lot of actually improvements that are good that should be in. So there's one where you have like a macro and then someone forgets to use the at in the name of the macro. Yeah, so there's a way to kind of where it kind of looks for things, and that could be improved. So, but maybe not today, or maybe not in this session anyway. I just wrap this up, I think. So we did a little of cleanup of the costs, moving them into normal expressions. Oh, here's something. If insert that. Okay, that was the unfold default. So it should add. There's also this. So we have like these built-ins. Some of them should go basically get more of them should be turned into expressions. So these are already in as expressions, but more of them should actually be normal expressions in this. And copy and mem move is actually things that you do in the when you do the lowering. So again, that could be probably moved. Okay, 800, almost done with the tests. So it should be ending up with 931 integration tests. The main cost here running these tests is LVM outputting the LVM IR. Okay, so we're done with this. I'm going to push this. And yes. I need to update the task, which you don't see. Now, implement a needs verification. So maybe I'll do one more. So this task is called this. Hang on. So it's called missing macro if symbol is not found, and this is just an improvement on the diagnostics. So we're just going to pull some code in here. So they made a check, which is something we can just do it even shorter. Just call it like that, and then trying to call it without the at. So what you do is maybe you put this in a different module. So you call module ABC. And then you're going to import it. So you import ABC from your module, which is called test. And then you're going to do ABC, check. And that's wrong. So in this case, if I run it now, it's going to say, boom. Oh, ABC check could not be found. You spelled right. Okay, hang on. So, okay, I didn't have any other. Maybe there weren't any other possibilities. Maybe I can just add in something called void share. Like that. And see if it finds, asks me if that's what I wanted. Yeah, so now it's going to ask me, do you perhaps want, this one? So now we're going to look for where this is added, this code. So here we are, module closest ident names. So what we're going to do is like if we are also going to do like, okay, we'll have these matches, right? And we kind of have a we're going to have find closest, right? And then we're going to have like so if the name, if the Declan, okay, so the Declan name, we're going to pull it out. And then we can replace that one where Declan name is. So, okay, so if name 0 is not, okay, we're going to check this out. Cool. Starts at, and the name is this. So if it starts, if it doesn't start with that, not starts at, and strict and decal name is at, and equals decal name 1 comma name, then we're gonna add this to like this is the best distance, so it's going to have like then the distance is going to be like 0. Otherwise it's going to be this. So we're essentially going to add this this as the best possible match if this kind of happens, right? Let's see what happens if I run this code now. Oh, now I wanted the ABC check, right? Maybe it was a bit bad to just call it 0. What happens if we have 1, right? 2. So maybe I should just have So we have 3 matches. The best one is going to be the last one, right? So it's just going to be okay. So let's take this one. It's going to be decal, and then we're going to have like count. It's going to be 1. No, it's not going to change the count. I want that separate. So something like this. Then we can just continue. And then we can just put this one back here, and then there's like this normal thing. And so if count equals to 3, or if it's equal to 3, if there is, okay, so no, let's see. So if there is not match, if count equals 3, then matches 0 equals that match. Else matches count plus plus equals that match. Something like that. Right, so then you get that. Okay, yeah, I think let's see if it breaks anything. What ASM are you transpiling it down? I'm using LVM as a backend, so LVM will basically lower it to whatever ASM there is. I'm working being loosely a loose term on a C backend as well, so that you can have it work with tool chains that doesn't accept that you are running LVM directly, or something that LVM has poor support for, which are some special things. So no ASM, or actually, but there is an inline ASM in the language. So so you can so but then that would be like just that particular which is completely unrelated. Never mind, forget about that. Okay, And I should perhaps, I'm just going to accept this enhancement on that particular task and write it down. So what would you call this? We call this missing macro if symbol is not found. Okay, release notes, and this is an improvement actually. So include at name when searching for possible matches to name the error message. Okay. Yes. And that has a number as well. It had a number which is 1. This task. So we can copy this one and include that one with the fix here. If it's done. Yes, it's done. So right. That pretty much wraps things up for me today. Thank you for watching and have a nice day. Bye bye.